E2E Energy Solutions strives to design and develop economical solutions for a sustainable net zero carbon future using its patent-pending process, Enhanced Geothermal Reservoir Recovery System. E2E's EGRRS process targets qualifying producing and non-producing oil and gas reservoirs and converts them into large-scale geothermal power plants capable of generating 50 to 100 megawatts. Two to four wells are selected within 4 kilometers from each other. The wellhead is removed off of the first injection well and the directional drilling rig is set up. The wellbore is then re-entered and drilled down to and through the reservoir, continuing to a depth that yields temperatures above 200 degrees Celsius. Once the desired depth has been reached, the drilling is then turned and continued to a central location where the recovery well will be located. The drill is then removed and the perforated pipe is installed in the horizontal zone. Once the perforated pipe is installed, the formation is hydraulically fractured. A second conduit is then installed in the wellbore and connected to the first. The portion of the conduit passing through the reservoir is designed to enhance gas liberation from the reservoir brine, which can then be recovered at the wellhead. With the gas removed from the brine, the hot fluid flows down the conduit to the fractured zone to complete the first injection well. The same process is then replicated at the second well and any additional injection wells that may be used. After all the injection wells have been completed, a recovery well is strategically located at a central location and drilled to the same depth as the injection well. Multiple horizontal legs are then drilled from the central recovery well, intersecting the fractured zones of the injection legs. The perforated horizontal recovery conduits are then installed, intersecting the injection leg's fract zone. The recovery legs are then fractured, creating a deep earth radiator at temperatures of 200 degrees Celsius or higher. As the hot reservoir brine passes through the gas recovery conduit in the reservoir, the trapped gases are liberated from the reservoir brine, which then travel up the conduit to the wellhead, where they are recovered. The remaining hot brine flows down the injection conduit to the created deep earth radiator. The hot brine then slowly flows through the fractures, where the temperature is upgraded to greater than 200 degrees Celsius and is recovered by the injection legs and brought to the surface. At the surface, the hot brine is passed through a separator, where it flashes into steam. The steam is then used to drive a turbine to generate electricity. The condensed steam and water are then treated and sent to the hydrogen electrolysis process. A concentrated brine is created after the steam is separated from the reservoir brine. This concentrated brine is then treated and sent to the lithium extraction process. The recovered natural gas from each injection well can be sold directly to market or reformed efficiently into hydrogen, utilizing the produced steam and generated electricity to power the SMR plus carbon capture process. The heat recovered from the lithium and electrolysis process, combined with the electricity and clean water produced from the geothermal power plant, can be used to heat and power sustainable greenhouses. The produced green electricity can also be used to power energy-intensive AI and cryptocurrency mining. The remaining water and any carbon produced are treated and re-injected back into the reservoir, away from the production zone. E2E Energy Solutions, with its economics-first approach to renewable energy, creates green energy projects with economics that make sense.